Alright, so what is the domain for this inverse sine and inverse sine square root of 1 minus x? So we know if we've got an inverse sine, we've already restricted x on sine. So we're going between -1 and 1. And if I look at the inverse sine of the square root 1 minus x squared, we know that's got to be positive and between -1 and 1, so that's between 0 and 1. If I square everything there, I get this. Yeah, and if I subtract 1 from everything, I get that. And if I swap, so flip the signs and times by or divide by -1, we put the 0 on that side now, and that's a 1. So that x squared is between 0 and 1. Now when x is between -1 and 1, x squared is between 0 and 1. So the domain over which we're looking is x is between -1 and 1. Okay, so that's fine. Now if we look at the next bit, if we need to differentiate from g of x, the first part's easy, of course. Inverse sine x, we just look at our formula sheet and we get 1 on the square root of 1 minus x squared. And then the second bit's a bit hard. So if I just make the second bit for a second, if I take that separately and let u, I'll do the u over here. U can be that 1 minus x squared to the half. So that makes it easy if I'm doing dy du. I'm using my formula booklet again. I'll just get that. And I'll come back to that in a second. If I do du dx here, I have a half bracket 1 minus x squared to the power of, that'll be a -half, and I'm not going inside for the chain rule, I get -2x there. Alright, so we've got all kind of this together. So you can see you're going to get -x on square root 1 minus x squared when we put that all together. Now over here, just remember that our u, what was our u? Our u is, so this u is the square root of 1 minus x squared. So u has to be positive. So when I'm doing 1 on the square root of, yeah, hang on, so u has to be positive. Here we go, yep. So this is going to become 1 on, so I've got, I'm going to get x basically, but it has to be positive. So I'm going to get, so in terms of x I should say. See, if I rearrange this, I'm getting u squared is 1 minus x squared, and x squared is 1 minus u squared. So x, why did I want to do that anyway? I just want, oh, okay, so x, oh, let's just make it u squared. U squared is this, and then when I put it into here, I've got 1 on the square root of 1 minus u squared, so 1 minus x squared. And you can see that that will just be 1 on the square root of x squared. And so it has to be positive, and it's 1 on x, but it has to be positive. So we write it as either the absolute value of 1 on x or 1 on the absolute value of x. Sorry, that was a bit long-winded. So if I go for dy dx now, I'm taking dy du, so this bit, times du dx. So I've got 1 on the absolute value of x times by -x on the square root of 1 minus x squared. So you can see there you get -x on the absolute value of x root 1 minus x squared, which is, and then if I put that part up here, I get that answer. I hope that helped a little bit. All right, but it's all there, so I'll rub this out. So we've got a bit of room for the next part. So hence, determine the interval over which g of x is constant and find the constant. Okay, so for g of x to be constant, if we differentiate a constant, so something that's constant, so if we differentiate that, we're finding the gradient function, which has to be 0, doesn't it, if it's flat, so it's got to be constant. So if we make this g dash of x equal 0, then that 1 on square root 1 minus x squared has to equal that x on absolute value x square root 1 minus x squared. Has to equal that. So if I rearrange that, I mean, you know, kind of this part and this part are the same, so I'm just getting, I could just times them up, but I'm getting the absolute value of x equals x. Just note though, of course, because of this stuff here, we know that x, this is where x can't be equal to 0. So where does the absolute value of x actually equal x? Well, absolute value of x. So this is where x is positive, and we've already said x is between -1 and 1. So where is x positive for that? Then x has to be, oh, have we said that? All right, so we're just saying, what are we saying? All right, hence determine the interval over which g of x is constant. So yeah, so at the moment we've got x be between -1 and 1, and here for this to work, this would have to be bigger than 0. So I think if we put those together, we're going x is between, so x is greater than 0. Here I go like this, so it's greater than 0. And sorry, this was originally like that. And less than or equal to 1. And then it would work. So and determine the interval and where g of x is constant and find this constant. So when g of x is positive, whoops,